ladies and gentlemen.
So let's talk trigonometry, specifically trigonometric ratios, and we'll get to those ratios in a minute, but before we do, it's important that we have a skill of identifying the sides of right triangles. What do I mean by that? Well, I have one labeled for us here. We have the hypotenuse. The hypotenuse is the longest side of a right triangle. It is the one opposite or across from the 90-degree angle. Something that's a little bit different is that I've marked one of our angles with the Greek letter theta, meaning the TH sound. Typically, we use Greek letters to signify angles, and theta is the most common one you'll see. Now, the legs of the right triangle, meaning the ones that touch the 90 degrees, have special names depending on their relationship to this angle. The one opposite of it, or across the triangle from it, is called the opposite leg, and the one next to it is called the adjacent leg. So, next to is adjacent, across from is opposite. So, let's practice real quick on identifying those sides. I will be using the letter H for hypotenuse, A for adjacent, and O for opposite, just for simplicity's sake. So in this triangle here, I see across from the right angle should be my hypotenuse. Across from my angle I'm given is going to be the opposite, and next to it is the adjacent. Another way to think about the adjacent is it's the leg that is in between the angle given to you and the 90. It's the one directly in between both of them. That's something that has helped a couple of my students along the way. In this triangle here, that side would be this one. It is the one between both of the angles, so that would be the adjacent. The one across from 90 is the hypotenuse, and the one across the angle, opposite. Finally, this one here, the hypotenuse is on the bottom, the opposite is across from our angle, and the adjacent one is in between. So, there we go. It doesn't matter how the triangle is oriented. What matters is where's the 90-degree angle and which angle is marked given to you. Now, it could be marked with a theta, or it could actually be marked with a specific angle measure, like 25 degrees. You have to be able to adapt on the fly for that one. So, why mention these names? Well, our trigonometric ratios are based off of those names. The sine ratio, not sin, we don't sin in math class. The sine ratio, spelled S-I-N-E, is the ratio of the opposite leg to the hypotenuse. The cos here, or as we say, cosine, is the ratio of the adjacent leg to the hypotenuse, and the tan that's written here is tangent, which is the ratio of the opposite leg to the adjacent leg. Now, these ratios, what makes them really, really special is that the angle determines the ratio. So we've talked about similar triangles previously, but if we have two of the same angle, the triangles are all similar, so their ratio should be the same. So that's kind of how all of this works, is if we fix one of the acute angles of a right triangle, then every right triangle we build off of that would be similar to each other and therefore would have the same ratios of the sides. Those ratios we call the sine, the cosine, and the tangent. You'll also see that each leg is used twice in the three ratios. Opposite is used for sine and tangent, adjacent is used for cosine and tangent, and the hypotenuse is used for sine and cosine. The opposite is always on top, as it is for sine and tangent, and the hypotenuse is always on the bottom, as it is with sine and cosine. Something that has been said numerous times and is a mnemonic that kind of can help you remember this is called SOHCAHTOA. So SOHCAHTOA. I won't give you the backstory I was given because it's kind of problematic. But SOHCAHTOA can help you out a little bit. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, depending on how far you want to go in your mathematical career, you have to have this memorized. And I would recommend, especially if you're doing a standardized test or you're planning on going into pre-calculus, calculus, that kind of thing, you have these encoded in your brain. Whether you remember them just as they are, as these ratios, as written, or as SOHCAHTOA, as long as it's down, that's all that matters, but it's gotta be in there. So let's take this and solve some problems with it. If cosine of theta is equal to 24 over 25 for a triangle below, which I did not draw. Find the value of tangent of theta. So let's draw that triangle. It doesn't matter how we draw it, just how we label it. So we'll put a right angle here, we'll put a theta here. So cosine is adjacent over hypotenuse. So the adjacent side for this triangle would be this one, so we'll call this 24. We'll call this side 25 since it's the hypotenuse. If I want to find the tangent, tangent is equal to opposite over adjacent. I'm missing the opposite side. I'm missing what this is. So I need to solve for it. And if I have two sides of a right triangle, I can find the third using Pythagorean's theorem. So in this case, 24 squared plus O squared should equal 25 squared. Now these are going to be big numbers, so if you don't have them memorized as squares, that's fine, but I do. 24 is 576, and 25 squared is 625, plus this O squared here. Now, to get the O squared alone, we're going to subtract the 576 from both sides. And that is ugly. We're going to need to borrow. So we'll make this a 5, we'll make this an 11, and we'll make this a 15. And then 15 take away 6 would be a 9. 11 take away 7 is a 4. And that leaves us 49 is equal to O squared, which means that our opposite is 7, because 7 squared is 49. So this is 7. If tangent is opposite over adjacent, it means that tangent is equal to 7 over 24. So tangent theta is equal to 7/24, and that would be our answer. All right. Next up, when Mr. Whaley parked his car at the airport, he spotted an approaching plane at an angle of elevation. That's an interesting use of phrase. Of 12 degrees. If his car's current ground distance from the plane was 5,000 feet, what is the plane's altitude at that moment? So, first thing we're going to do is we need to set up a problem. And since we weren't given a picture, let's draw one. We have a right triangle being described. Our plane is here, so we can draw like a little plane if we want to. Beautiful. And then Mr. Whaley's car is here, so we'll just put a little blob there with wheels for the car. We have an angle of elevation of 12 degrees. The angle of elevation is formed with the ground going up. So it's always formed with the ground. So this angle here is 12 degrees. And it says that the car's current distance on the ground is 5,000 feet. So this is 5,000 feet. What is the plane's altitude? Altitude is vertical height. So we'll call this altitude, we'll call it a capital A for our intents and purposes. So let's set up an equation. Well, first thing that we need to do is we need to identify what sides we have. We have this side here, this would be the adjacent. And we have this side here, which would be the opposite. Opposite and adjacent means that we're going to be using tangent this time. So tangent of our 12 degrees is equal to opposite over adjacent. So in this case, A over 5,000. And we're going to solve for the A. How do we get the A alone? Well, we're dividing by 5,000, so let's multiply by 5,000. So that means that A is equal to 5,000 times the tangent of 12 degrees. Now, this is not something that you can do by hand. There are some special angles and some special tricks that we can use later on, but we really don't have anything for this, so we have to turn to the calculator. So now that we have a calculator open, our angle is specifically in degrees. So if you look at the top right part of my calculator here, it says radian. So that's not how we measure our angles right now. So we're going to go to the mode, and we're going to change our calculator to be in degrees. Once you change it here, as long as you don't reset your RAM, it should stay in degrees. So once you do it once, you really don't have to worry about it. My kiddos usually have to switch between both because I teach some lower level and some higher level classes. So I have to train them in both. So good habit to always check your mode before you use any sine, cosine, or tangent on the calculator. So now we can quit by going second mode to quit. And we're going to just type in what we see. We have 5,000, so 5 and then 3 zeros, tangent, and then 12. Since the 12 is in degrees, we don't have to put a degree mark, and enter, and we get an answer that is A is equal to 1062.78, and our unit for the distance is feet. So feet on our answer, and that is the altitude of the plane. So not too bad, but again, we can't do that one without a calculator. The last thing we're going to talk about for our right triangle trigonometry is that the fact that the sine and cosine have a complementary relationship. That's actually what the co from cosine stands for, is complementary sine. So basically what that means is that if the angles for sine and cosine are complementary, meaning they add to 90 degrees, then the sine and cosine are going to be the same. So in this case here, if I have this angle here and I add it to this angle here, 90 minus theta, if that equals 90, then this statement is true. And if I do, these two would cancel out, give me 90 is equal to 90, which is true. So that is why it works. So let me give you a small example of that over here. If I have the sine of 30 degrees is equal to the cosine of theta. What is theta? Well, the angle inside of a sine and the angle inside of a cosine, for them, the actual sine and cosine to be equal, those angles have to be complementary. So 30 degrees plus theta has to equal 90 degrees, meaning that theta has to equal 60 degrees. So that's an interpretation of that, and that might be a problem that you come across in the future. So how are we going to apply this here? What kind of problem are we going to solve? Well, if we have a triangle ABC that is a right triangle with B being the right angle, if the cosine of A is 1/3, what is the value of sine of C? Well, let's draw the triangle. And in doing so, let's label the right angle as B. We will say that this is A and this is C. So the cosine of A is 1/3. So the adjacent over the hypotenuse for A is 1/3. The sine of C would be the opposite over the hypotenuse, which would be, in this case, also 1/3. So the sine of C is 1/3. Why? Well, this angle here and this angle here have to add up to 90 because there's 180 degrees in a triangle, and 90 of those degrees are already being used, which means there's only 90 left. So whatever angle A is and whatever angle C is have to add up to 90, meaning that we have the cosine and sine of complementary angles, which means that the values are going to be equal. That is it for us. I know that was a lot in a short amount of time. If you have any questions, please let me know. Practice makes perfect, and I look forward to seeing you in the next video.